All right, let's get going. So today is our last lesson on imperative programming. And that, sometimes people ask, well, what do I mean by that? You'll see. When we get to objects next week, we're going to talk about, Java is really a very heavily object-oriented language. It's a language that really sort of puts objects first. For the purposes of instruction in this class, what we've been doing over the past 4 weeks is we've been hiding things from you in terms of some of the object-forward parts of Java, mainly because I don't think they're the right way to introduce students to this material. So some of you that have some background in Java have maybe been a little confused by this because you didn't see things presented this way before. But starting next week, we're going to introduce Java's object model and class system, which is pretty exciting because that's the point at which we've been using Java's type system. So we've been using strings, which is one type of data. We've been using the primitive types. We've been using arrays, but we haven't had the chance to design our own types. And that's what you can do with Java by using Java's object model. And so for the next sort of month or so, we're going to be talking about sort of how we design our own types in Java, how they work, and how we can work with them and use them to improve our programs. And that sort of represents both a step forward in terms of how we work with data, but also a big conceptual step forward as well. So that's pretty cool. But so today is our last chance to kind of finish up these basic sort of non-object oriented programming paradigms. And there were a couple things that we covered today. And again, I'm just gonna kind of like ramble here for a few more minutes, and then we'll get to some questions. There were just a couple. These are like, again, I mean, I don't know. I feel sort of obligated to sort of finish out the Java keyword bingo card. It's like, do students really need to see continue? There's people that are like dead set opposed to continue in loops. They think it's terrible and you should never use it. I don't know. I mean, it's there. So I feel like there are things that I want you to see, even though I don't expect you to use them very often. So continue kind of falls into that category. There are some places where you might use it, might find it convenient for you. There's other times when you're going to see it when you're reading other people's code, and so that's an important thing to get used to. Switch is another example, right? And switch, is one of those things that until maybe last time I taught this class, switch was like this little footnote that we would put up on a couple of slides and move on from quickly. The only thing that's made switch suddenly much more interesting is Java's decision to innovate in switch, in new versions of Java, which again, in the lesson I talk about, I find this weird, but whatever. I'm not in charge of Java, so I don't get to tell them what to do. But and again, I feel like maybe there's a rationale here in the sense that if you're going to start experimenting with some new language features, you might want to do that experimentation with things that people don't tend to use, and switch is not something that people tend to use very often. Now, the idea behind, one of the things, and I'll go over here to the lesson and we'll look a little bit at switch, right? So this paradigm, and let's see here, I'm going to actually just play this quickly so you can kind of see where this goes. So this paradigm of switch does appear in other languages in a much, much, much more powerful form, which is sometimes known as pattern matching. And I'm not going to kind of go down that rabbit hole completely, but the idea of being able to match, so you can think of what's happening here in the switch statement, right, as sort of pattern matching. So I'm taking this variable number and I'm trying to match based on these different cases to figure out what to do. And that actually turns that programming paradigm, although it's not particularly well exposed in Java, does actually play a big role in certain other programming languages and a major role in certain functional programming languages where pattern matching becomes like a really key tool that you use when you're writing code in that language. It's just not something that's a big part of Java. So again, switch is sort of a curiosity and has become even more so, I think, recently because of the Java developers' decision to kind of start to mess around with switch a little bit. And in particular, this idea of switch statements now being able to be used as expressions. That, again, as somebody who programs in languages that allow this, I find very exciting in the sense that maybe Java will get there. Now, I sort of don't care because I don't use Java for a lot of my own stuff. I use a language that's like Java, but it's not Java. It allows me to program in ways that interoperate with Java, but not have to use Java. But at the same time, it's still healthy, I think, for Java to move forward and to innovate and to advance. And so that's kind of cool. And we're welcome to talk about that. That's probably something people have questions on. Although, again, it's not material that's really sort of core to what we're going to evaluate or assess you on in this class. But I thought it was fun to show you because, you got like technology. One of the things that's so much fun about technology is that the field changes all the time. And you guys are part of that now, I know that that's I know very, very well, having been doing this for 20 years now, that is a big double-edged sword. On one hand, it's exciting because there's new stuff coming out, and maybe I'm just sort of an optimist at heart when it comes to technology, but in my experience, the new stuff is better. We're actually making progress. It's not always super fast. It's not always linear. Sometimes things go backwards, right? But if you look at the programming languages and tools that are available today versus the ones that were available 10 years ago, I think we've made a lot of progress as a community towards building better things. And so that's exciting. On the other hand, it can be sort of exhausting to be part of this field. You know, if you think like, oh, I'm going to learn this stuff and then I'll just settle down to a life of comfortably writing Java code for the rest of my life. Yeah, good luck with that, right? I mean, not that you can't do that, but those types of jobs tend to be dull because you're working on stuff that's not changing very fast, and it's kind of like, you know, I mean, yeah, there's somebody who's still maintaining all the Fortran code that we wrote in the 60s, but like, you know, and that job may pay very well because there's very little competition in that space. But is that really what you want to be doing? For some people, yeah, sure, right? But I think, you know, some of us that are, you know, drawn into a life of technology are drawn by this sense of change and excitement and innovation and development that's going on. And so, you know, there are some days when you wake up and you're like, oh man, you know, something new came out, some new thing to learn. I just learned this one thing and it already feels outdated. And there's other days where you look at that and you're like, wow, that is so cool. I'm so excited by this new idea. I can't wait to try it. And you do see over time how the ways that you're working now are more powerful and more effective than they were in the past. So anyway, you got both those things together kind of in unstable mixture. So and then the other new thing in today's lesson, and actually, you know, given what we've covered in the past in this class, this is actually new. And this was one of those things that when I was thinking about what to do this semester, I'd had this in the back of my mind for the past couple semesters, just like I really should teach that because it's so useful. And so we're going to show you how to use assert. And this is a way that you can include certain types of assertions or statements about things that should be true, right? So an assertion basically says at a particular point in the program, I'm going to put in a statement of truth regarding some variable, right? Like this variable should have this property or whatever. And if that assertion is false, at that point in my program, it's going to crash. That's what's going to happen. The assertion is going to cause your code to crash. Now, I talked a little bit in the walkthrough here about, like, that seems insane. You know, our code crashes for all sorts of reasons, usually because stupid mistakes on our part. Why would we ever want to purposely cause it to crash? And on some level, the idea behind an assertion is that when you cause a crash due to an assertion, you're kind of taking control of the situation and you can have a little bit more of an understanding of what happened and what went wrong. When you don't include assertions, what can happen is that assumptions that you made about your code that turned out to be not true can then cause problems later on that could be a lot harder to figure out. So it's like, you know, like let's say that you're assuming that let's say you're working on some code with a partner or in a group, and you know somebody told you read the documentation for this function and it said, you know, the return value of this function will always be in that range from 0 to 8 or something like that, right? And you're like, okay, well, I can assume that now, and you're doing things in your program. Maybe you have a fixed size array. You know, maybe you're using a byte variable to store that because you're like, it's small, so that's okay. So you're making assumptions about that. And if those assumptions turn out not to be true, there's all sorts of weird things that can happen at that point. So, you know, asserting that something like that is true can be helpful. You know, it makes sure that, you know, the assumptions that you made about things are correct, you know. And I like going back to that example we did with Sudoku because we did some checking of the board in order to be able to make certain assumptions. But it still would have been okay and maybe justifiable to actually insert some of those assumptions into the later pieces of code, right? Where we assert that a particular value is in a particular range or whatever. And that'll just sort of help sanity check things as we go. So asserts there, it's a part of the Java language. We've turned it on in all the homework problems and on all the playgrounds now. And so this is something that you can use in your code to kind of test your assumptions as you go. And I kind of walked through an example of that, sort of preparing you to finish the homework, the string rotate left problem. And again, the way I'm doing string rotate left is sort of, there are other ways to do this as people pointed out in the forum. If you can figure out how to use substring to solve this problem, and that's a pretty cool solution. And in that case, you don't need to do this, but the solution approach that I'm pursuing is one where an assertion ends up being a kind of a nice fit because it helps identify an assumption that we're making about how the remainder operator works in Java that turns out not to be true and is about to cause a problem. All right, so what do you guys want to do today? So I'm finished with my ramble. I will now take questions from the audience. So we can go through some of the assert examples. We can talk about switch expressions, which again I think are really cool. I can show you some. I mean, if you want to see, if you want to see this model of pattern matching and of statements as expressions taken to a more complete expression, I can show you some examples of Kotlin code, which is a variant. I shouldn't say it's a variant of Java. Kotlin is a different language that's been designed to interoperate with Java, and it's a language that I'm very fond of and I do a lot of my work in. And it actually has syntax so that if can be an expression, and if statement can be an expression, it can be used to assign a variable. And it also has a kind of a better version of switch that's known as when. That's a little bit more, even a little bit more friendly from a syntax perspective. That's also pretty powerful. So we could look at that if you kind of want to see, because in my opinion, this is very much where these changes in Java are coming from, right? I mean, Java is realizing that there are other languages that are out there that have started to kind of like compete with it for different, for developers, right? I mean, languages, you might think like, how does language design work? You might have like, who comes up with this? I mean, languages are designed by human beings. And in many ways, languages compete for relevance by kind of trying to convince developers to use them. And there's a variety of different ways that happens, right? Through, support for different types of tasks, through adoption by various different platforms. So we've talked in the past about how Java has been really helped out by Google choosing it for Android. But some of it also comes down to like just, the quality of the language itself, right? What sort of features does it offer and stuff like that. And, Java, I think as a language was kind of like in this very, so if you look at kind of like what are the most used programming languages in the world, Java's been up there in like the top 3 or 4 or 5, maybe even the top 3 for a long time. And, it's a very venerable language, but it's not, like time moves on, right? And Java is now encountering competition, I think, that it hasn't experienced for a while. Some examples of, happy to show examples of an assert, yeah. Well, let's see here. Let me think. So, I'm just trying to think of what to show you guys that would actually make. Yeah, okay. Hold on a sec. I'll pull up some code to show you. So again, I don't write a lot of Java, but I will show you some examples of assert-like statements in a different programming language. So hold on a sec. Let me pull this up and figure out what's a good thing to use. Let's see here. See if I can find a good Okay, yeah, let me pull this up for you. So, and again, it's the code that I'm going to show you. I certainly don't expect you to understand, but I will. And this is my code, and I will kind of show you. But I will sort of let's see here. Gotta get this guy back. Okay. All right. So let me see if I can zoom this in a little bit. Can I? Zen mode. I don't want Zen mode. I just want you to. I want the text to be bigger. Is there a way to do this? Appearance. Toolbar. Hold on a sec. Control-Shift A, it says. Okay, let's try this. That didn't seem to do anything. No. All right, well, I hope you guys can see this. That's my only concern. And again, I wish that there was just try a few more things here. Enter presenter mode. What's that going to do? Okay. Oh, that's probably better. Yeah, hopefully that helps. Let me make sure that it's still actually visible on the stream. It may not be. Okay. I think that works. All right, so let's do this. So again, this is not Java code. I'm assuming what you guys were asking to see is like, how would you actually use assert, right? It's not Java code, and so what you're seeing is not assert, but it's essentially the same thing. So this is in a language called Kotlin. This is a state. This is oh no, don't do random stuff, please. Okay, this is a statement called check. And it's really the same thing as assert. The syntax is a little bit different. So what I have here is I have a condition that has to be true. And if the condition is not true, what's going to happen is that there's going to be an error generated, and this is the message that's going to be used. And I can go through, again, what the details of what this code does are sort of unimportant to you, although I'd be happy to try to explain it at a high level. This is, well, anyway, I won't go into that unless somebody asks. But the point is that these are located throughout the code to try to make sure that my assumptions about things are correct, and also to make sure that I haven't made other mistakes. So for example, this piece of data, and again, some of the syntax here is going to make a lot more sense to us after next week, although it's different syntax, this is a different language. But this is a single data point that represents a location within, or sort of a location within a file. So it's like a range, right? It starts at a particular location. You can think of it as like a range in a string. It starts at a particular location and ends at a particular location. Well, a valid range should have the end location greater than or equal to the start, right? I can't have a range within a string where the starting location is at an index that's greater than the ending location. That would be invalid. And in this case, I'm creating these data points, and so this would be a bug in my code that I would be able to identify, right? I'm doing something wrong. So that's one example. Let's look for some other ones, right? So again, so you can see, I mean, this file has maybe, almost 1,000 lines in it, but there's quite a few places where this gets used, right? So this is another place where I'm doing some string manipulation, and I'm trying to just make sure. So I'm basically taking a string and I'm dividing it into 3 parts. And I'm trying to make sure here that when I divided it into 3 parts, the 3 parts that I created still add up to the original string. So imagine I have a string, I'm trying to figure out how to divide it into 3 parts, and how I'm dividing it is not important, but the idea is that the 3 parts should still together equal the original string. And then there's some other things here that I'm sort of checking as I go that have to do with how this piece of code actually works, right? And again, we can just kind of keep going here. So there's 16 uses of check. Here's another one. So this one I can try to explain as well. This is kind of an interesting one. And this is actually one that I'm familiar with because I hit this one recently. All right, well, you guys have really pushed me into digressive territory, but here we go. So the goal of this piece of code is, imagine I have a piece of Java code, and I want to make a small change to it in a way that changes the behavior. What we use this for is we use this for testing. So we take a small piece of Java code that represents the solution to one of the homework problems, and we make a tiny little change. Let's say that I have a loop that goes in increments of 1. I might change that to increments of 2. I make that tiny change, and then I rerun the test on this changed code, and the idea is that the test should identify it as incorrect, right? Because if the solution, if our testing approach is correct, it should identify these small changes as wrong, right? So let's say you're summing all the elements in an array. If I introduce an off by 1 error, right, then the sum should be incorrect because you missed 1 element. And I can do that by, instead of going to length, I go to length minus 1. Or I could also walk off the end by changing the less than to a less than or equal to. So I make these small changes. The idea is that the small change is actually supposed to modify the file. So if I take this, or the contents, you can think of this string containing Java source code. If I take the Java source code and I apply one of these, they're called mutations, kind of a nice name, then it should be different, the result. And this check right here, so modified is now the mutated content. So I've made some small change to the code. And the idea is if my mutation approach is working properly, the modified should not be equal to the original. And this is Kotlin syntax. So this is essentially equal to modified dot, it's equal to modified, not modified dot equals original. So this is string equality, but this is Kotlin syntax for it, which is a little bit nicer. So anyway, and again, recently as I was working on one of the new homework problems, I hit this assertion. And it turned out that there was a bug in the code that I had written for making changes to strings. And actually the bug was that if you had a single character, and again, this was something that I just hadn't written a test for yet. So if you had a string literal that consisted of a single blank space, the mutator would change that to a single blank space, and so it wouldn't change the contents. And so as I was, so essentially what happened is, as I was working on writing one of the homework problems, I was running the code and it hit this assertion. And so I saw this message that said mutation did not change the input, and I was like, huh. And so because I had that in there, that led me right back here. This was literally like 3 days ago, right? It led me right back here, and it led me right to the source of the problem. Within, I would say, 20 minutes, I had a new test case that I had written that identified the problem in this particular piece of code. And then I had found a fix for it and made the change, and then this went away. So this is an example of, again, if you take some source code and mutate it, it should be different. If it's not different, then something's wrong, right? Because you didn't actually make a change. And so again, this is an example of, now, had I not had this in there, there would have been another problem that this would have caused, but that problem would have been more difficult to diagnose because I wouldn't have understood what caused it. And so by putting this in here, I actually had a very, very good idea of exactly what the problem was, or what the root cause of the problem was. I didn't know exactly what it was, because if I had known exactly what it was, I wouldn't have made the mistake, but it helped lead me in the right direction, right? So this is an example. And again, I'll kind of stop here if I can get this to go away. How do I get out of presenter mode? Appearance, exit full screen, and then appearance, exit presentation mode. Okay, yeah. But so this is an example of use of an assertion in the wild. It's not C++. This is Kotlin. But again, so the idea, and let me go back to my other view here. Oh yeah, it's me trying to figure out how to zoom in. So the idea here was that by placing these assertions in there, and again, that file had 16 of those assertions. It's not assert, it's a different thing, but it's the same thing, right? Those are there to check assumptions as the code runs. It's just a different syntax, it's a different language. But by having those in there, it actually became much, much easier to find. And again, out of 800 lines, you had 16, so you're talking about one every 40 lines or so. That sounds about right, in the sense that, you're not using these all over the place. But again, they're like that one that I just showed you really saved my butt the other day, because had I not had that in there, like I said, there was something else that was about to go wrong that would have been caused by that. But I would have been scratching my head for a lot longer about what the cause was. But because at some point, I had thought, and here's the other thing about these types of statements. Once for those of you that are just getting started with this, again, you may think, I'm making a lot of mistakes now, and then at some point in the future, I won't make as many mistakes. But that's not really true. What happens is that you get better at fixing the mistakes. But the other thing that you get better at is knowing that you're going to make mistakes. So that assertion that was right there, right? You might think like, gosh, you've been doing this for 20 years and you're still not sure that this piece of code that you wrote is correct. And it's like, I'm less sure now than I was 20 years ago. In fact, I'm pretty sure that it's probably wrong, but I may not find how it's wrong right away. So I have enough skepticism of my own abilities, enough realization that I have made similarly stupid mistakes in the past, to put that type of statement in there. as a sanity check for myself, right? So this is like past me helping future me, because past me knows that future me is probably going to be back looking at this piece of code trying to figure out why it's wrong, and past me is like, here, let me give you some hints. Let me try to help you out by making it easier for you to identify what the problem is. And so on some level, these can be sort of a sign of humility and a sign of just an understanding of your own limitations. Like, you're not perfect. You're not going to get, everything okay in there? You're not going to get everything right the first time. And assertions are a nice sort of way to codify that in your own code, right? To kind of make sure that, it's just, like I said, I mean, that assertion, right? I don't even remember writing it, to be honest. It's not like that was a big moment in my life, I think at the time I was probably like, oh, I'll just put this in here just in case, right? And then, like I said, a couple days ago, really, really helped me. So that can also be something that can happen. The one of the things that happens over time once you start working on bigger projects and with a larger group of people is that a lot of people start to modify your code as well. The other thing that assertions can also help other people understand your code. And maybe that's something that I should have emphasized more in today's lesson, but we talked a little bit about comments and the importance of comments, but on some level, comments are, I would argue that a good assert or the check statement or whatever I was using in Kotlin is actually more valuable than a good comment because it's code. And so if somebody's reading my code, they see, okay, at this point in the program, the programmer wants to be certain that this thing is true. I could have written that in comments. I could have put a comment and said, at this point, mutated string should be different than original string. I could have just written that down. But then the computer can't help me check it. Well, with an assertion, a human can read the assertion and they can say, oh, okay, at this point, this had better be true. That's what the programmer thinks is supposed to happen, right? That's what's supposed to be correct. But the computer can also help, right? The computer can also check that for me and be like, oh gosh, it's wrong, and then throw a big fit about it and then help me find out what the problem is. So assertions, a good assertion, particularly with a nice message, right? So that's why I would encourage you, if you're going to use assertions, to use this syntax where you also include a message, right? Because now when this assertion blows up, you're going to see that message in the error output. And so somebody will, here's what happens when one of these blows up, right? This is exactly the same thing I did the other day. You run back to that piece of code, you find that line, you look at that assertion, you're like, why is this failing? And so having an error message in there is almost like a comment, right? It's almost like a comment, but it's a comment that the computer can display on your behalf when that turns out to not be true. So anyway, so this is, and we'll continue to try to help you, learn this by demonstrating it in our walkthroughs and in the homework problems that are coming up. Homework problems are about to get a lot simpler and more conceptual for the next couple of weeks as we start to talk about objects. But when we get back to writing trickier bits of imperative code, which we will at the end of the semester, we'll come back and we'll kind of revisit some of these ideas and use them to kind of make our code more easier to read, and then also sort of more robust against failures. So, all right, other questions? It's a great question about assert. I could also show you. Again, like I've got asserts all over the place. Let's see here. So if you look at, I can show you where would I do this? Yeah. So, so this is, I'll pull up this code in a second so you can see it. And let's see, nope. I need to swap this out here for something else. Here we go. Yeah, so another example of asserts. This is the backend code for our new quiz system. And, here's an assert, here's an assert, here's an assert, here's an assert, This is, again, a different style of code. It's TypeScript. So the asserts look a little bit different. But, you know, let me see how many of these. Oh, they're all over the place in this, right? So assert, so you got assert, 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 assert. I mean, it's just throughout the entire thing, right? I mean, you've got them all over the place. And it's really, you know, kind of on some level the same approach, right? It's, you know, this is code that runs like when the web client requests that the backend do a certain thing. And so there's a bunch of things that we want to check. It's like, okay, because there's a lot of, there's data that the client is providing to us that could be totally bogus. And so we're trying to figure out if it's okay. And so, you know, this is a place where, you know, another place where asserts get used heavily. And so and these also have a slightly different syntax in the sense that if this fails, what happens is and you guys will talk more about this later in the semester when we talk about web APIs and when you guys start working on the machine project. When the web API fails, it causes an error code to be sent back to the browser. So the browser makes a request, like let's say, in this case, the request is trying to close an assessment. So this is what happens when the teaching staff closes your quiz. So we're checking some things here, and one of the things we're checking is that so you can close your own assessment, right? And so the idea is if the assessment.created_for is an email address, and so if that's equal to the email address of the person who's making the request, that's okay. Or the person is staff, or the assessment is a practice assessment. And so if none of those things are true, we're going to return an error message, right? And so the idea is like, if you tried to close your friend's assessment because you were like a joker and you decided to mess around with them, you wouldn't be able to do that. This assert would fail, right? So again, another use of asserts in the wild. Although, wait, what happened? Why am I looking at? Sorry. What happened here? Why is this? I thought that I had switched over to here. Okay. I guess maybe it got confused, but anyway, so let me just walk through that again. So this is code that runs when you hit the close button next to an assessment or when a TA does it for you. And so we check to make sure that you can close the assessment by evaluating this if statement, which has this conditional expression. Again, this is TypeScript, not Java, but it has three parts. It checks either the assessment was created for you can close your own assessments, you're a staff member, or the assessment is a practice assessment, which is also okay to close at any point. So anyway, so that's that's another example of a sort of different context. And there's nothing super secret about this, but I'll close it just not to expose too much of the details of our web backend. Good debugging technique. Yeah, so we'll talk. We're probably going to do some work on debugging as sort of part of the machine project. The homework environments that we have set up for you are not great for debugging. They just don't really have a way to kind of attach a debugger. But once you start working in Android Studio, we'll be able to do that. I think so. Debugging is typically considered the practice of trying to figure out what caused a problem after it's happening. The best way to debug your code is to not cause bugs in the first place. And I know that sounds, like, well, duh. But there are actually good strategies to avoid writing buggy code, and we've been trying to help you kind of learn those. So using assert is one of them, right? If you put asserts throughout your program, and those asserts start to fail, it allows you to learn that certain assumptions that you were making in your code are true. And then when something goes wrong, you don't have to, it's not as hard to figure out why it's going wrong. The other, good strategy is to work in small pieces. The homework, one of the reasons why we don't really, focus on this in the homework is the homework are all pretty small. And so they're not complex enough where there's really kind of strange things happening. But once you start working in bigger code bases, the idea of writing tests, right? So you can think of this as sort of forward debugging, right? These are things that you do to avoid having to debug, right? Because to some degree, here's my claim. Once you start debugging, you've already sort of lost because at that point, you're in tough shape, right? And so anything you can do beforehand. And so, my 3 big steps, I think this semester we will show you how to use the debugger in Android Studio. It's sort of a frightening experience because it's suddenly like this big, complex tool that you're being exposed to. But we'll provide some walkthroughs and we'll kind of go through how to use it to kind of solve a simple problem. And, to be fair, from time to time, I do break it out when I'm really confused about something and I can't figure out what's going on. But best strategies to help your debugging is to work in small increments, right? Don't try to, the more lines of code you write at once, the more likely there is that there's a problem with what you've done. So that's the first strategy. Second strategy is, use asserts to help identify the assumptions that you're making and make sure that they're true. Third step is writing tests, and we'll show you how to do that. I mean, we're not going to have you do it. We're going to provide tests for you, but on the machine project, we'll go through and show you kind of what tests look like and why you would write them. And when you actually go off and you do your own development, testing becomes an incredibly important thing. And here's the thing that people don't understand about testing. A lot of people, I think that testing is like drudgery. It's like not writing real code. It's writing these test suites. But a good set of test suites gives you a tremendous sense of confidence and satisfaction. So, sometimes if I'm working on some code and I'm feeling a little frustrated or I'm feeling like, oh man, it's taking a long time, I'll just run the test suite for the whole thing. Because a lot of the projects I work on, we've written over the years and months we've been working on them hundreds and hundreds, dozens at least, if not hundreds. I have the playground backend that we use to run the Java code that you guys submit through our playgrounds probably has at least 250 tests, I think, at this point. And so every time I run that test suite and all those tests pass, I'm just like, yeah, it still works, right? And of course I know they're going to pass because I've run that test suite hundreds of times, but on some level it gives you this really nice feeling of satisfaction, right? To see all those green check boxes and to kind of remember man, I did all this work, and it's all still working, Of course, again, it's a computer, so it should be pretty deterministic, but yeah, test suites and writing tests can give you a huge, the little thrill you guys get, when you pass one of our homework problems, right? It's like that, but multiplied by 200 or 250 when you're running a big test suite. And so it's a great way to help push back against the general sense of frustration and difficulty that you can encounter while programming. So is to have good test suites, write them, and when they pass, it's going to make you, it makes you feel confident. The other thing it, of course, allows you to do is if you end up going back later and making big changes, you can rerun the test suites and make sure everything is still working, right? And that's actually, again, a huge, huge source of satisfaction and confidence, right? When you don't have good test suites and things work, you're scared to change anything because you're afraid that stuff might break. When you do have good test suites and stuff works, you feel free to change anything because you know that if you break something, you'll know about it and you can fix it or back up and decide not to make that change or whatever. So it just gives you a tremendous sense of confidence and satisfaction, but we'll get there. All right, so I think that's probably enough digression for one day. Thanks for everyone for joining. So there are weekend homework problems, just as a reminder about that. They're fun ones. We're also going to post a practice midterm this weekend. It won't have any multiple choice questions, but it will have programming problems on it that are of the level of difficulty that we expect you to solve on next week's midterm. And we're also going to use it as a chance to just, get you guys to bang on the quiz framework a little bit over the weekend and see if we can identify and fix any additional problems that we might run into, so we can avoid kind of any big issues on Tuesday. All right, thanks for joining me. I hope you guys are doing well. It's a beautiful day here in Champaign if you're around, a beautiful fall day. I know there's lots of parts of the country that are, under dark clouds of various kinds right now. So I hope that if you're one of those places, stay safe, take care of yourself. I'll be back on Monday.